Now we're going to learn how to predict the products of a double replacement reaction. So as a reminder, a double replacement reaction, I like to call it the wife swap reaction, and that's going to be whenever the metals and non-metals switch partners. So you can see my metals here are A and C, my non-metals are B and D. Before the reaction we have A with B, but after the reaction A is going to be partnered with D, and C, our other metal, is going to be partnered with B. It is important that the metals always go first and the non-metals always go second. When we're predicting products for a double replacement reaction, we want to make sure the metals in the reaction switch partners, and then we're going to rewrite the formulas, balance the reaction, and then we're going to predict any precipitates, which I'm going to come back to that. First, let's just look at the first couple of parts. So down here I have 3 double replacement reactions. I know they're double replacement because we don't have any single elements anywhere. And first thing we're going to do is make sure that all of them switch partners. I'm going to start by making sure I know which ones are the metals and which ones are the non-metals or polyatomic ions. So calcium's my metal, potassium's my metal, chlorine is my non-metal, and sulfate is my non-metal, or in this case it's a polyatomic ion. And so now I need to make sure that they're going to switch partners. So my calcium is going to come together with the SO4, which is sulfate, and the chlorine is going to come together with the potassium. As always, I have to write out my elements with their charges and make sure I'm writing the correct formula. So if calcium is going to pair up with SO4, which is sulfate, we're going to have calcium, which is +2. I have to look up sulfate in my polyatomic ion chart, and I would see that it is SO4 -2. So since our charges cancel out, the formula for calcium sulfate is going to be CaSO4. I'm going to do the same for the other compound. So my metal's going to go first. So I have potassium. Potassium is +1. I have chlorine. Chlorine is -1. So that is going to just be KCl. I'm going to go ahead and balance this. So it looks like to balance it, all I have to do is put a 2 right there. Now that I'm balanced, the last step I have is to circle any precipitates. So let me tell you what a precipitate is and how do we figure out if we have any. So the definition of a precipitate is a solid, insoluble product of a double replacement reaction. The key word there is insoluble. So most of the time when we're doing a double replacement reaction, these are going to be done in solutions. So a lot of our reactants are typically going to be dissolved in water when we react them. So when we mix them together, sometimes they form a solid product, and that solid product is called a precipitate. And the reason that it is solid is because it's not soluble in water. So if you ever have a product, that means the right side of the arrow, that is insoluble, that means a precipitate is going to be formed. And the way that we tell it's insoluble is by looking at our solubility rules. Your solubility rules can be found in your reference packet on page 6, but here's a smaller version just for us to look at. So it's organized into 2 sections. It lists all the soluble compounds and all the insoluble compounds, and they're organized by whatever the non-metal is. So nitrates, chlorides, bromides, iodides, fluorides, sulfates, carbonates, hydroxides. I'm gonna zoom in a little bit better. So these can be a little bit tricky because some of them have exceptions. So if we read carefully underneath the soluble category, the second bullet point here says that all chlorides, bromides, and iodides are soluble. But there's an exception. It says except silver, lead, and mercury 1. So this is telling us that compounds that end with chloride or bromide or iodide are all soluble. Anything, sodium, magnesium, potassium, calcium, aluminum, anything that ends with chloride, bromide, or iodide are soluble, except silver, lead, and mercury. So silver is Ag, lead is Pb, mercury is Hg. So that means even if it's a chloride, a bromide, or an iodide, if it's bonded to one of those three metals, it's not soluble. So you have to be really careful when you're reading these. So let's go back to our example that we were working on. So these are our products of this double replacement reaction. We're gonna circle any precipitates. So we need to figure out if these products are soluble or not. So let's start with calcium sulfate. I'm gonna find, so since I'm looking at sulfate, my nonmetals are sulfate, I'm gonna find on this list where it talks about sulfates. So it talks about sulfates right here underneath the soluble category. But if I read carefully, it says all sulfates except calcium. Since this is calcium sulfate, that is going to be insoluble. Since it's insoluble, that is our precipitate. We should only have one precipitate per reaction, but we'll just check on potassium chloride just in case. So potassium chloride, all chlorides are soluble except silver, lead, and mercury. Well, this isn't silver, lead, or mercury chloride, so that means it is soluble, which means it's not a precipitate. Let's go ahead and start on these other two examples. So I'm going to start off by predicting my products. I need to make sure my metals switch partners. So my sodium and my potassium are going to be switching partners. That means I'm going to have a compound between sodium and bromine. And I need to double check. Sodium is +1, bromine is -1. So that means we're good to go there. And then I'm also going to have a compound between potassium and OH. OH is hydroxide. Potassium is +1, hydroxide is -1, so we're good there. So that's just going to be KOH. Once I have both my products, I need to make sure I'm balanced. There's actually a typo on this paper. This 2 is not supposed to be there. So sorry about that, but I can check this over and I'll see that it is already balanced. So now all I have to do is predict any precipitates. So what I have here is sodium bromide and potassium hydroxide. So let's check our lists. So I'm going to look for bromides first. So all chlorides, bromides, and iodides are soluble except silver, lead, and mercury. It doesn't say anything about sodium bromide, so that means sodium bromide is soluble. Let's check on potassium hydroxide. Under the insoluble list, it says all hydroxides are insoluble. So you would think that this is going to be our precipitate, but let's keep reading. So it says all hydroxides except group 1A, or group 1. So group 1 on the periodic table does have potassium in it. Potassium is in group 1. So that means all hydroxides are insoluble except group 1 hydroxides. That means this is soluble. I know it's really tricky. You just have to read really carefully, but potassium hydroxide is also soluble. So this is not going to have a precipitate. All right, here's our last example, MgCl2 plus K3PO4. Why don't you go ahead and pause this video, see if you can predict the products so your metals are swapping places. Once the products are predicted, make sure you write the correct chemical formulas for them, and then check the solubility rules to see if there's any precipitates. So I'll pause this video and try it yourself. All right, now I'm going to work through it so you can see how you did. So magnesium and potassium are trading places, which means magnesium is going to partner up with phosphate. Let me make sure I'm writing the correct formula. Magnesium's +2, phosphate is PO4 -3. That means they do not cancel out. We're going to have to crisscross. So the correct formula for magnesium phosphate is going to be Mg3 PO4 2. So magnesium partners up with phosphate. That means potassium is partnering up with chlorine. We actually already did potassium and chlorine up here, so that is going to be KCl. Now I'm going to balance it, so I'm going to start with magnesium. To balance out magnesium, I need a 3 right here. To balance out my chlorine, I now have 6 chlorines, so I need to put a 6 right here. To balance out my potassiums, I need a 2 right here. And my phosphate works out once I put that 2 right there. So there's my final balanced reaction, and the last part is to predict a precipitate. So we're looking at magnesium phosphate. In our solubility rules, it says all carbonates and phosphates are insoluble except group 1A and ammonium. Group magnesium is not in group 1, so that means magnesium phosphate is insoluble. So since magnesium phosphate is insoluble, it's going to be our precipitate. Potassium chloride is soluble, so we don't have to circle that one.